So Wednesday, you're gonna look about less.
I did, I told you. It's not open.
Less.
Alright, guys, are you ready to start?
Yes.
Yes.
The mic working well? Can everyone hear
No,
me?
not at all.
Thanks. The mic?
Not at all.
Gonna have to use those.
I mean, I can use them, but you're not gonna hear them in their.
That works.
Is this mic working or no?
Sorry, I took Sunday for 5 minutes.
You're working or no?
Mic check, 1, 2, 1, 2.
Yeah.
Just raise your voice, it's a small class.
The problem is the recording.
Oh.
That's a skill, that's a skill you need that.
That's the
That's
only
a skill.
problem.
Can't watch it on 1.5 and then live.
No. Okay, I'm gonna wear my AirPods. Okay, so I'm gonna be using my voice for the one where it's right now here, and then the AirPods for the recording.
That works.
Not to listen to music, they tired of us.
You gotta jam out the whole session. What type of music listen to?
My main one is metal and hip hop, like old school, like. Tupac, you know.
Jada.
Oh,
Never
yeah.
mind. I can hear you guys.
You know, people that really like Vinny Paz, I heard of Vinny Paz. Self-titled. After me.
Okay, so somehow the mic is working because I can hear you guys.
What? You said what?
The mic is working. I can hear you.
No, we just have loud voices, that.
That too. Okay, wait, give me 1 second. I'm gonna mute myself here. And then this one's supposed to be working. Hello. Hello. Okay. Okay, I think we're back. Guys! The audio is working, so let's begin. Sure, go for it. Okay, thank you. Either way, first of all, before we begin with the review session, how many of you have already taken the extra credit exam? Raise your hand. Okay, that's not that many. Okay, the ones who haven't taken it yet. When are you taking it? Tonight? We're just waiting until tonight? Doesn't it close today? Oh, okay. It's closing tomorrow. Oh, he just keeps it open. Then you're good. Okay, got it. That's good to hear. But after the session, I'm gonna have tutoring sessions tomorrow and Wednesday. The schedule is right there at the bottom for everyone to see. It's at the SOC. Hopefully you guys know where it is. Raise your hand if you don't know where the SOC is. Okay, no one? That's good. So I'll be there tomorrow from 9:30 until 1:30. It's gonna be 4 hours. And then Wednesday, 9:30 until 11:30. But keep in mind, you can join both sessions. But Wednesdays tend to be a little more chaotic because it's the day of the exam. So if you know that you're gonna get stressed out or confused, don't go. Just chill. Just relax. And that's it. Well, let's get started with the review. Now, as always, you have the content review in there. You guys can check that out on your own. That's fine. We're still having conversations. Sam. Okay, just ignore the chapter 17 portion, okay? That's gonna be for your final. It's not gonna be at all on this exam. But let's get started with chapter 15. And this is already posted on their file, so everyone should be able to access that. But let's start with something simple. IUPAC. Okay, do we have an answer? Maybe B? Does everyone agree with B? Yes, you guys are absolutely correct. Okay, so in that molecule, what of the substituents has the highest priority? The carbonyl, the aldehyde specifically. Okay, and yeah, it's just B, pretty simple. Remember that you needed to memorize certain names, like toluene, aniline, all of those guys. Okay. Next, this one. We did something similar during SI today. Again. Okay, I have 1.44. It's not the same problem as SI. Yeah. Okay, I have 1.4 E and 1 for B. I have 1 and 1. What else? 4 as well. 4 as well, and you guys are absolutely correct. It is gonna be 4. Now, we talked about this in SI, but how do we solve questions with 2 benzene groups? What do we have to do? So that's a great question. So first of all, whenever you have 2 benzene groups, you're always gonna split it in half. And then you're gonna look at what's directly connected to each of the benzene groups. The one on the left is first connected to the carbonyl group. God, I really wish that the microphone would work. Okay, so after you split your benzenes right in half, you're gonna look at what's directly connected. So on the left side, it's the carbonyl group that's connected first. Carbonyls, what are they? Activators or deactivators? Deactivators. And then on the benzene on the right, we have a carbon chain. What's that, activator or deactivator? Activator. Whenever we have an activator and a deactivator, which one gives you the major product? Activators. So the one on the right is gonna be the only one reacting. Okay, questions on that one, we're good? Okay, that one should be pretty simple. Okay, I have one word for A. A. Someone on that side. What do you guys think? What's the answer for that one? We have 2 votes for A right now. Nitration. So it's actually alkylation. Now why? Can someone explain it? Nick. Because it forms a carbocation, meaning that we can have rearrangements. Therefore, we're not gonna have the same original carbon chain. So NH2 does poly substitution, not undesired poly substitution. Alkylation. No. Just alkylation. Yes. 1. No. NH2 That one is one of the strongest activators because it's so strong, it's gonna add everything at once. So it's doing poly substitution. But this question specifically is asking for undesired poly substitution. And that's always gonna be your alkylation. Okay. Okay, let's do that one. You have to rank the molecules. What do we think? C, B, C and B. What else? C as well? Look at the order carefully. I heard D, B, and if you said B, you're absolutely correct. But let's talk about it. Okay, so they're asking for the decreasing order, right? So we're going from most to least reactive. Most to least reactive. That's the order that you want. Yes. This is chapter 15. We're still on 15. Now, for that, you just have to look at the groups directly connected to your benzene group. How many activators do you see? Only 2. Those 2. Which one is the strongest activator? Number 2. That's why it's here. And then it's going to be 5. Then we're left with 3 deactivators. What about the reactivity of deactivators? How do you know? Which one? NO2 is the strongest deactivator, which means that the less reactive. That's why the halogen comes before the actual strong deactivators, and then NO2, that guy is the strongest deactivator that you're gonna have. One. Which one's the most reactive? The halogens, any halogens, yes. Between ketones and aldehydes, yeah, carbonyls are pretty much around the same thing. Okay. He's not gonna be asking you specifically aldehyde, carboxylic acid, the difference of those, yeah. Halogen before ketone, yeah. Again, please read the questions carefully. Okay, this one should be easy, I hope. I have one board for C. What do we think? Okay, what is the question asking you? Beautiful, exactly. That's why C is gonna be the answer. Because again, keywords, deactivates, and ortho and para. Only for halogens, exactly. Okay, questions on that one? Pretty simple, it's just conceptual stuff. Let's keep talking about conceptual stuff. B and D. Oh, B, sorry. What else? B as well? It's not as simple as it seems. It's not as simple as it seems. Read the questions carefully. Think about exceptions. Think about chapter 9, actually. E. Remember, they're asking for the true statement. One vote for C. You all got it wrong. So. Shit. Okay, it wasn't supposed to be true. It was supposed to be false. Excuse me. The story of the hexagon benzene has facility. That one's false as well. Damn. Wait, what? Okay, hold on. Addition rather than substitution reactions. Okay, so let's just go statement by statement. Yeah, let's just ignore the question for now. Again, typos are on my end. But A, benzene tends to undergo addition rather than substitution reactions. Why is it false? Why? Exactly. What about B? All of the hydrogens. Is that always true? Yeah. Yeah, if there's no symmetry, then they're gonna be separate. Theoretically, you can see all the signals separate or different. So yeah. And this one, let's just say through in general. Yeah. What about C? Think about the orbitals that I showed you during that side. The orbitals. I did show you the orbitals, Sam. What was the main difference between benzene and cyclohexatriene? Both. Now, remember, actually, let's go back to the chapter. Yeah. Okay. This is back from chapter 14, when we were talking about aromatic compounds. Now, technically, you are correct because double bonds and single bonds are going to be at different lengths. What's going to be longer, single bonds or double bonds? Single bonds. Now, specifically talking about cyclohexatriene and benzene, they're going to be different because if they alternate short and long, then it's going to look really, really weird. So it's not really stable. Benzene, everything is going to be relatively equal to each other. Yeah. What about D? True or false? False, beautiful. Last one. B wasn't supposed to be the answer. I was attempting to show you guys another question. It wasn't. Okay. Let's just fix this one right now. Okay. Yeah, no, I was thinking about another question. I typed something different than what I was thinking about, but yeah. Either way. All but B. Okay, let's talk about 7. 4, D. Everyone agrees with D? Yes. Okay, why are we so sure that it's D? We talked about it in the slide today, and I mentioned it so many times. So yeah, just know it. Just know it. Okay, so again, keywords, rate determining step or rate limiting step, they're the same exact thing. And then it is gonna be D. The ones that produce or form the uranium ion. Because that's the one that takes the longest. Let's go back to the mechanism here. Okay, look, in the very first step, benzene is going to be the nucleophilic attack to the electrophile. After that, whatever electrophile was there, it's getting connected, meaning that now we went from an sp2 carbon to an sp3 carbon. Therefore, we're losing the aromaticity. So if we're going to something unstable, that's not good. Okay. Let's see that one. Okay, does everyone agree with C? Okay, we have one more for C. What do you guys think? Everyone else? Are you going with C as well? Those are all of the options. A through E. Yes. It was one of the questions. Okay, so the answer was actually C for this one. They were asking. Should be positive. Overall charge has to stay the same in every single resonance form. So that positive, instead of being on a carbon, it has to be somewhere. In this case, it was the halogen. A is not the same thing. A is a secondary carbocation. Tertiary, secondary, primary. There we go. Okay. Sorry? Overall, it's going to be more stable. It's in the tertiary position and it's also allylic. So it's perfect. Say that again. Guys! Just go for it again. Vinylic is unstable, yes. That's when the carbocation is directly connected to the double bond. Gio. B is not tertiary because we just consider our groups as carbons, not the bromine, really. Okay, next one. Should be pretty simple, I hope. It's always a Lewis acid. Remember that. Always a Lewis acid. Okay, what about the 10? You're thinking about chapter 16. What do we think? Okay, Emily says C as well. And you guys are absolutely correct. It's gonna be C. It's just asking for the reaction that's not gonna happen. And again, key part, Friedel-Crafts, that's the only one that has special rules. So benzene is just a single ring, that's it. What about B? What does it have? A benzene with what? A benzene with chlorine. Option C, a benzene with what kind of group? How does the nitro group look like? NO2, it's just NO2. Toluene, how does it look like? Just a methyl group. And then the other one is pretty self-explanatory. It's just benzene with a chicken foot. That's it. Okay, let's do 11. This one it's slightly different and it's bringing back Orgo 1 concepts. Yes. And we got quiet. What's the answer? This one has multiple steps. And you're actually starting with the Orgo 1 concept first and then the Orgo 2 concept. You're gonna do a reaction from Orgo 1 back in chapter 8. And then that's when you proceed with the benzene reaction. Oh my god. Okay, best guess. What do we think it's the answer? A? What about on the left side? D? A? We're going with B. Say that again, sorry. Guys! One. Just a little bit. Okay, go again. Isolation will be the one that does the Friedel group. It's not gonna be the phenol group per se. Okay, let's work through this one. You were correct, Sam. Yeah. Sam, how do you solve the question? Yeah. Okay, yes. Okay, just tell me the main two reactions that you did. What are their names? It is going to be alkylation at the end, but hydrate shift is not a reaction. Okay, it's just a rearrangement. But let's talk about this one. Again, they're just asking for major product. We know that we're doing an alkylation with benzene, just benzene. But then we need some sort of alkyl halide to do an alkylation, right? That's the main reagent that you need. But you're given 1-butene from the HF. Yes, so that means we have to make the alkyl halide first. Okay, so that's butene. This is my first step. Butene with HF. This is from Orgo 1. Does anyone remember the name of that one? What's the general mechanism? No. If you're going from a double bond to just pure single bonds, you're adding something. No, addition reactions. You're adding something. That's back in chapter 16. Think of Orgo 1, chapter 8. Chapter 8 was all about your addition reactions. Specifically, this one, it's hydrohalogenation. It was one of the very first reactions that we talked about during Orgo 1. Okay. So just to save some time, you're adding the fluorine in the more substituted side of the double bond because this guy is more Markovnikovs. Once we do the addition reaction, now we're ready to proceed with the alkylation. So, yeah, double bond attacks the hydrogen, breaks the bond away, you form a carbocation in the most stable, and then fluorine just attacks and gets connected in there. Mhm. Okay, so yeah, fluorine goes away. You're left with a secondary carbocation. And then you're just adding this guy. Okay, yeah. Okay, questions on that one. I think that's the only complicated question that you might see on the exam. Yeah. Okay. Now, does everyone see why B was the answer now? Okay, we're good. Emily. So yeah, remember, parent chain is going to be the longest continuous carbon chain. So this was 1, 2, 3, and 4. That's the longest continuous carbon chain that you can have. Benzenes, we can either just call them a benzene whenever they're the parent chain, or a benzyl or phenyl group. For this guy, it looks like sec-butyl, yeah. Yeah, no, your professor is not really going to be using sec-butyl. Yeah. Guys, no. Wait a second. Go, Emily. The benzene in this case is going to be the substituent. Okay. Yeah. Why do you say that? No, you guys are confusing the concepts. NH2, what kind of functional group is that? Functional group. Amines. Remember, no reaction with amines. In this case, what kind of reaction are you doing? Bromination, a halogenation, simple as that. It can react. What's the answer now? Oh. D, 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 and B. Okay, so this one was actually B. Now, NH2, that's an acid. Oh, then you're good. You're good, yeah. People, let's talk. God, I want my microphone. I want my microphone so bad. Oh, and it's that, okay. Yeah, it's just that. It's not working at all. I tried, either way. And yeah, the 3 microphones, they're all off. So if anyone knows how to turn them on, you're more than welcome to come up to the podium, okay? NH2, that guy, it's an activator. And that one, it's the strongest activator. And remember, I wrote a word down when I showed you that guy, polysubstitution, meaning that you're gonna add in every single possible, exactly, at once. You're gonna add everything at once. That's why 2 was the answer in this case. Undesired polysubstitution. Yes. Emily. In alkylation, yeah, this reaction is not gonna happen because of the amine. If you have NH2 and you're trying to do an alkylation, it's just not gonna happen at all. Because remember, amines and strong deactivators are the ones that prevent Friedel-Crafts reactions. Question? It's the strongest activator. No, we don't really know about the weakest deactivator. If you have just chlorine, yeah. Okay. Any other questions on that one? We're good? Okay, we all see it. Oh. I can't see from that.
You're referring to this little snippet right here, correct?
Partially, yeah.
Okay, so you're saying that alkylation as well as NH2 does polysubstitution.
NH2 on its own, that's the strongest activator. That's the one that can do polysubstitution. Yes, the only activators. Now, remember, NH2 it's an amine, so it's never going to be able to happen with alkylations or acylations. Now, undesired polysubstitution, that comes from your alkylation. Why? Because we do the rearrangement. Okay, so undesired,
Okay,
that's it.
so acylation doesn't do anything. It's just an accident.
That's it, yeah. Okay, next one, guys. 13. Is it working now? No, not at all. A little bit. Damn, that's not good. One? Okay. We'll make it work, yeah. We'll try. Okay, I have one word for one for this one. Read the question carefully. And we just talked about this. It is 5. It is 5. Okay, let's go through each of the reactions in this case. Ooh, yeah. The pair position should give you a predominant product. But either way, ortho and para, they're not the reason why the reactions are not working. First of all, that guy is an alkyl halide. What kind of reaction are you trying to do? Alkylation. What's the rule for alkylation? Exactly. So this is not gonna happen at all. Same process for the other one. NH2, alkyl halide, doesn't happen. Benzene with alkyl halide, that does happen, but you have to be careful. So this carbon chain is not the same as the one presented in there. So that's not the major product. Yes. Yes. Remember, any amines or strong deactivators are the ones that prevent all of your Friedel-Crafts reactions. It's the strongest activator, yes. NH2, yes. It's too strong. No. It doesn't go because Friedel-Crafts reactions do not work with any amines or strong deactivators. Abigail. 5. 3 is gonna happen, but they're not showing the major product in that case. The major product comes after the rearrangement. Say that last part again. How do you know which one's gonna be the major? Sam, guys, just 1 second. Abigail, go. Okay, that's better. The activator for amines, yes. Yes, the one that gives you more than 50%. Mhm. It wasn't an alkylation, it was a halogenation. It was just pure halogens. You're thinking about this one. Yeah, it's not the same reaction. This one. It's not only because it's the H2O, but you have pure halogens. There's no carbon chain. Don't worry, you got it. Okay. What I just told Abigail? Remind me the question again, please. Okay, yeah, I just remember. Okay, so in this case, we know that they're asking for the major products because it says that they're produced at 50 or more percent. Something that's produced more often, that's your major product. Now, this reaction was your alkylation. Why? The reagent needs to be a carbon chain with some sort of halogen. Now, we know that NH2 prevents that reaction from happening. In the previous reaction that we just did, we had NH2, but the opposite happened. We did polysubstitution, but we're not doing the same reaction. This guy is just pure halogen, so it's just a halogenation. If you see halogen with carbon chain, that's a different reaction. Questions? Very good. Okay, let's do this one. At this point, it should be pretty simple. We think it's 5. Five, and you guys are absolutely correct. It is gonna be 5. Now, same process as before. Split it in half and then look at what's directly connected. On the left side, carbonyl, that guy, it's a deactivator. On the right side, we have a nitrogen. Nitrogen has lone pairs, so it's an activator. So we're only gonna be reacting with this guy. That's it. 1. Or amine. The rule is that it doesn't work with strong deactivators or with any amines. Okay. So far, any other questions? We're good? Okay, now let's take an 8-minute break because it's been an hour. So we're gonna take a little break. So you guys can go to the bathroom, get some food, water. Say that again. It's not 4 because that's the meta. Yeah. That guy, it's an activator, so it only goes ortho and para. Again, quick little break, stretch, talk outside, and then when you return, stop talking that much. So. Okay. Okay. This one. Mhm. 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 Exactly. You have to see the relationship between the two groups that you have. In that case, they're pair, so the only one that can give you the pair position is by doing tile elimination. You're kidding. Juan, did you ever do a SI in any of the rooms in GS? Do you know how to turn them on, the microphones? But never one of these. Oh. They're locked. I just will learn now. Yeah. I'm not. Wait, is it because of that?
You might,
They're
you
muted
know,
now.
that turn.
Yeah. I just raised the volume, so I thought it was gonna work. Is it working? Is it working? Hello? Why is it low? I just increased the volume to the max. Hello? Guys? Abigail? Can you hear me? Yeah. No, you stay there. No? Okay. It's locked. Yeah, I tried. It's locked. You need a key. We don't have a key. Usually you can fix it with the panel down here, but it's locked. Yeah. Yeah. Either way, we tried. That's fine. Thank you. If you can, yeah, sure. Thank you. We still have 4 minutes, so. Well, that's okay.
I have a lecture. I'll probably look at the next.
So, you know, like the anti-aromatic, aromatic, and non-aromatic stuff? Is that pretty good? Because it was on the Friday.
Yeah, it shouldn't be on this exam. Yeah, that's what I saw. I'm not sure why he included them. It shouldn't be. But again, most of you got them correct. It was like 90% of you who got it.
Also, as long as you remember the items, you should be okay, right?
Is it working? Is it working now? No. No, it's not working at all. Wait. Is it working? Is it working now? Hello? But it has to be directly. Wait, you can hear me? Okay, that's way better. Okay. Give me 1 second.
Okay, it's still working? We're good?
Yeah.
He's so lost. Because I was.
So we don't want the chlorides in
We
the.
just got it working.
Oh.
Yeah, we just got it working. Well, thank you.
Oh.
Yeah, it works, right?
It's really good.
Oh, it's not working anymore.
Your crap.
Yeah, that's still kind of low.
Hello?
Yeah, now it is.
Okay, yeah, I just need the microphone like right next to you, my mouth. Hello?
Yeah. That's a lot better.
Better?
Yeah.
Better?
No.
What about there?
Yeah.
Here?
Yeah.
Yeah. Okay.
It sounds better, appreciate it. Wanna go higher?
Higher? What do you mean?
Louder, you mean.
Sure.
Can I do a little louder?
Louder's always better.
Wait, they're the ones who, oh,
Alright, that's it, appreciate it.
thank you.
Yo, this man got hookups. Gotta make a phone call. One phone call, that's all it takes.
Okay. Finally.
Alright. Bro, that's a lot of that.
Can you hear me?
No. You're gonna have to make it work a bit.
Okay, we're just gonna be right. Okay, let's just keep going with the review.
Ring B and aeromethylene. Hey, you good?
You don't think it's safe?
Yes. Constitution occurs in ring B, Paris.
Yes, we can slow down a bit. Thank you for telling me.
I can't even read it. You don't know you asked that. He has the thing on his tablet.
Because it's all one on one molecule.
No, but the nitro group.
What do you think?
So,
Same process as we did before, you just split them in half.
So with that being said, in a fatal Krebs oscillation, you cannot have reaction. Electron.
oh, he's arguing the fact that that whole molecule is interconnected. So how would you go through a Cradle-Krafts if there's a nitro group technically connected to the ring?
So E.
But it's, I feel like it's way too far from the ring.
I put A originally, but I'm just seeing it now.
He wants to argue.
You were initially correct.
Yeah.
It is gonna be A.
I feel like it's just way too.
Okay, now, same process as before, guys. Split it right in half. Left side, deactivate. Right side, activators.
Yeah.
So the benzene on the right B is gonna be the only one working. That's it.
We the best music.
Questions? We're good?
Nope, 16. Okay.
Yeah.
Baby, let's go. Oh, that's what it was.
Let's do this one. It's still 15.
Listen, I got one, but I'm not sure why.
We got a 1, okay.
What?
Hold up, I know the Cl protonates the O, which gets rid of.
Emily,
That's benzene.
H
No.
is whenever the benzene is connected to something else.
It's not.
Lonely benzene.
Okay, so far I just have 1 vote for 1,
2 votes for 1.
2 votes for 1. What about the back?
Oh, yeah,
One
just,
as well?
1 for 1.
You guys are absolutely correct.
Watch should be like wrong, like, oh, you got.
Can we please go through that?
Yeah.
Okay, so the very first step is just SOCl2. What's SOCl2?
So cool. Second group.
Protecting group. So we're just swapping the OH for whatever halogens. After that, we're reacting with benzene and an ethyl group, acylation, we get rid of the chlorine and then attach the rest of the carbon chain. That's why 1 was the answer. Okay, questions on that one?
Hold up.
a second.
I'm just gonna go over it again. So first reaction, SOCl2, protecting group, we swap OH for whatever halogen they're given. And then for the second reaction, we have our acyl group, that carbonyl, which is our halogen. And then we have benzene, so we're doing an acylation. We get rid of the leaving group, the chlorine. And then we attach the rest of the carbon chain that you have with the acyl group and your benzene group.
Love it.
That's it.
The other protecting.
So what's the-
Protecting shows SCL5.
Benzene groups.
It was a bunch of like
reactions with
the,
benzene.
PCC something.
It was all of the reactions with benzene groups. We had 5.
ECC was an oxide.
Calculation, acylation.
Yeah, PCC oxidation, I had it.
Yeah.
Can we go through the protecting groups really quick?
Yes.
Give me 1 second.
Oh, it's right up there. Well,
Oh, sorry, 15 was A.
Yeah.
16?
15 was A,
Well,
16 was A as well.
Okay.
Yeah.
There you go, protecting
Protecting
groups.
groups, God bless.
You guys have access to that. It's in the content
there.
review portion.
And then what about group two or the chemistry, do we need to know those or?
For group 2 for this one, no, not really. That's why I just called it out.
With a good lead.
Okay, we're good?
PB.
Let's make it a.
Well, which one?
Okay, we'll go for sure, in one of these times.
You want
Go for B.
This.
Wait.
The
Reaction.
You guys are absolutely correct. It is gonna be B.
Oh, yeah.
Let's go in one of the possible positions, ortho. Remember, we have chlorines. What are chlorines? Activators or deactivators?
Ortho is deactivated.
Ortho pair deactivators.
Yes.
So
Yes.
the only one showing that relationship
This part.
is molecule 2.
Yeah.
Thank you. And it won't go in between them because
They're
they're hindrance.
hindrance, yeah.
This one is not gonna happen at all. Not really. This one.
Anhydrous aluminum chloride.
This is the full expansion.
No, what one? We have one vote for 2.
Feeling it's 2, I just wanna know why.
We think it's 2. Anyone else?
Bro, there's gonna be a ring.
CL3.
Thank you. It's gonna be a bigger ring, I think.
No, would it be? Is it a ring expansion?
Oh, is it a, he's arguing for it in the sense that the carbocation maybe after creating that carbocation.
It is gonna be 4.
A ring expansion.
Okay, what kind of reaction are you doing in there?
Not buying any disrespect to you, feel me?
And everyone on that side. I'm just gonna wait for you guys.
That's it, baby. You said what?
I'm gonna wait for you guys.
AL.
Okay, we're good? Okay, so the answer was 4 in this case. What kind of reaction are you doing there? What's the name? It's an alkylation. That's the one that forms a carbocation. Once chlorine goes away, you're left with a primary carbocation. How can you make it better?
Do a ring expansion.
Ring expansion. And at the end, it's just gonna end up in a negative position. You just add it into your bank, and that's it. Simple as that. Question?
Nope.
Yes,
How does she know say you just put it into the tertiary?
because we still have ring string, so we wanna try to fix that.
Oh, that's a good point, right?
Mhm.
Just do a hybrid chip to make it. Tertiary.
You always wanna make the most stable molecule overall, not just the carbon.
Computer's at,
I have no idea.
how long have you had it?
I'm on your gears. man.
Okay, 19.
You better give mom a hug.
Always.
What do we think?
Not embedded directly.
No one's the choice of the note. It's directing, which means, so what's the
A.
deactivator?
A.
No, hold on.
Wait, NH, yeah, it's A.
How you gonna get?
It's definitely not D because D, wait. Oh, I
Yeah.
thought you said E, I thought you said E, my bad.
D.
It might be D, it might be D.
Isn't D?
Oh, wait a minute, but
that's
D
a
has
strong
the
character.
positive charge.
So that's gonna go on middle position.
Okay,
My boy, we're talking about 19.
Yeah, NO2 can go. NO2
No,
yeah,
hold
that's
on.
the one. That was the only
Might be C.
option that I got for adding a second one.
So it's a deactivator.
Okay, final answer. What is it?
Not a meta directive, so we need an activator, we need an activator. I'm going with A.
Oh, no, we need an activator.
That's what I just said.
Right, because it's, no, ortho para.
Okay.
We need anything that goes ortho here. Everything but meta.
I'm going A, I'm going A.
Is in the meeting.
Absolutely right. It is gonna be A.
He's gonna say it's not metaphorical. You're right.
What functional group is that?
Going crazy.
What's that?
It's a quick break, came back.
Oh, wait, no, it's amide. This is carbonyl with a nitrogen.
Them, hopefully you guys remember them. They're all strong deactivators that go meta. Yes.
So the amide is the reason that, cause the amide is.
CN is a.
It depends on the connection. In this case, we're shown that nitrogen is first connected instead of the carbon group. So that nitrogen has lone pairs. Lone pairs. activate.
You're right, you're right. The only thing that's weaker than that is
Okay.
NO2 and then NR3. NR3 is the strongest one. Yeah, that's.
The QR code, you need it again? No, you just have to do it once. Did everyone scan the QR code at the beginning?
Yes.
Yes, ma'am.
No. You didn't?
Floral methods
But looking at these, I like understand.
will nitrate. No, so.
Maybe you didn't, so in the first half,
But it's.
you don't have to re-scan anything.
Just have a bot that's
Trifluoromethyl.
I understand.
Just have 100 sign ins, right?
This is the C wave, that's not the C.
Then how you gonna have a methyl?
Okay, we're all good? Like we are. Let's go back.
Trifluoromethyl, I'm pretty sure it's assuming. No, it's like one methyl and then there's three fluorine.
Correct.
Question 20.
Yes. If it touches the halogen,
Will.
groups, are they gonna deactivate it toward the layer of it, since it touches the carbon, it's gonna be.
Okay, but we're gonna go by the strongest activator.
No, this is 3 fluorides on a carbon that's on the benzene. They're pulling electron density, so
So this is the molecule that we're looking at, correct?
no, it's 3 fluorides on the carbon, that's a single carbon with 3 in the benzene.
You're bugging, really?
That's it, there.
Trifluoromethyl?
Are you sure?
You tripping, you've been overstudying, bro.
Where?
No, for sure.
Is that how the molecules?
And then methyl and then-
You're missing one carbon.
Okay.
It's the benzene with one carbon, and yeah.
That's some.
So.
Cluster.
So then it's.
Just pulling electron
So-
density, slowly.
So it's the carbon.
Electron withdrawing.
Medical.
Oh, yeah.
No, I mean, yes. Yeah.
We have an answer.
Delta.
D,
Delta, does everyone agree?
delta,
D?
Why?
Yeah, they're absolutely correct.
God bless America.
Because
EF3, what's that? Activator or deactivator?
Deactivator,
Weak or strong?
weak, strong.
Strong.
the slow reaction.
No, remember, deactivators, they slow down the reaction, because with a strong deactivator, we're going to the meta position. That's it.
Oh, if it's not reactivated, you need to wait.
Sorry?
I'm sorry,
I think one of the deactivators that we talked about during SI, it should be in the chart.
Yes,
I saw Emily first. Oh.
You said what?
Where does that fall?
in general.
It should be a deactivator. Did I include it? in the chart?
This chart.
Yeah. That's what I was
I don't think it's.
Which chart?
At CF3,
It's CF.
all the way to the right.
Right?
All the
So
way
it's, wait, it's even stronger, it's a stronger deactivator than, the,
NO2.
yeah, the NR3 with plus.
Yeah.
I feel like it'd be.
No, but I'm
it'd be
not
weaker
quite
than-
sure, so don't quote me on that.
I feel like it'd be weaker than the, NR3 plus, because the plus charge in itself, like, the electron withdrawing. Yo, where's Dr. Webster?
Dr. Germain. She's the better chemist. Won't be one. Love you with chemistry.
There we go. CF3.
Okay.
It makes the most efficient chemicals using the ingredients.
That's CF3 to your list, of strong deactivators. You're not gonna see two. Yes, if they're gonna be just more on your phone, or CF3.
Said two, how about one? You should about four.
Okay, next one, 21. Should be simple. You don't have answer choices this time.
general, these are the three steps. Formation of the uranium ion, right? Uranium ion.
Carbocation first. Wait, hold on.
Hold up, you say carbocation, he's saying uranium, I think it's uranium.
Second one is uranium.
Think about the 3 steps.
Oh, yeah.
The second
Not
step.
skip anything.
It says and blank ion.
Oh, yeah, you're right, you're right.
Proton,
And then.
Formation of a,
electrophilic aromatic substitute. Yes. Why would you would form it, like,
sometimes it's present, but sometimes like, you know how like, it has to react with something to make it.
you're talking about the catalyst, so you need it.
Remember about the Lewis acid.
Lewis
Lewis acid is the one that makes your electrophile more electrophilic.
So without the Lewis acid, it just wouldn't.
The reactions are not gonna proceed.
Oh,
Yeah.
okay, so you would.
You need a Lewis acid.
Form the electrophile, okay.
Okay, so that's the first step. Then what happens?
Then the uranium ions,
Beautiful.
and then loss of a
Proton.
proton to reform the aromatic system.
That's it. Simple as that.
What is this, McDonald's?
Dab it off, dab it off. Fuck up, that's strong.
What about question 22? What's the answer for that one?
Two different picture for the stronger activator.
Stronger activator.
Shannon,
Yes.
EAS is what, electrophilic addition.
EA Sports.
Electrophilic aromatic substitution. Okay, last one. What about 23? What's that?
Yeah.
It's just the activators.
The electron density. Oh, yeah, because it's withdrawing, yeah.
Questions? Again, it was just conceptual stuff. Okay, and now we're gonna be moving on to chapter 16. Okay, any last minute questions on 15 at all?
So.
Are you good? That's it for 15. I think I just have one more problem at the very end.
Wait, so, wait, this was just like all 15?
All 15.
No, 16.
We're gonna talk about 16 now.
Oh.
So don't worry. Okay, we're good. Okay, I hope that the first 2 questions are very easy for you guys.
It's B and then A.
No, it's B.
Converting the water. Oh, yeah, we just went through this class. It's B.
Okay, let's start with question 24.
This is
You're adding water.
the.
Water is your reagent. What's the product that it forms? Diol. What happens if I have an alcohol group?
Then it would be if you have an alcohol, wouldn't that be like a hemi acetone?
It can be hemiacetone.
Oh, right, because you already have the H on the.
Yeah, it depends. But in the-
It's one of the reactions that succeeded.
Water always creates a gendiol. What about question 25? We talked about it so
So-
many times.
So why is A not it? Because the carbonyl group. Oh, that's it. Oh, yeah.
Diol looks like this. Laminal looks like this.
See that, yeah.
Base.
Sophisticated.
Okay, what about question 25? What's the answer?
D.
Oh, that was, I like that. It was
I just took a piss and I got to.
That sounds like a skill issue.
Let's talk about IUPAC.
J.
No, hold on, no, don't even circle anything. Go out at the fourth carbon.
Seven, wait, is this?
A 1,
Yeah, it's D. Little fucker.
2.
Simple as that. Yeah.
Oh, yeah, right there.
No, this is easy.
What about molecule 5? I'm gonna start at the carbonyl and then, do I go left or right? Why right?
Beyonce said so.
You wanna have the-
Exactly, you want the lowest number.
Oh, sounds right. You're just confusing me. 3.
Whoa, 1, 2, 3, 4, 3. That's a 5.
Wait, no.
Sorry.
3 times. It's not B.
That's not 3 as well.
If it's AL, it's just one exercise. Part of the.
Right, so
The known.
It's either AL or ONT
There we go.
on a ketone, so you can get rid of D or E.
what's the full name for molecule 5?
Very first one.
Questions? How to do with iPad? What's the ending for aldehydes?
AL.
Beautiful. Yes.
Or can you just put?
Oh, yeah, sorry. You're supposed to include both locus. No, what's the name for that molecule?
One. Oh, B, yeah, B.
What is that?
It is gonna be me. Organic from the carbonyl that has the aldehyde. And then you move to your.
Said that though. You gotta start with this.
Questions on that one? Pretty simple. What about that one?
Oh, you're right.
It's in condensed formula this time, slightly different.
No, not even just these, they're close
So
together.
the alcohol gets the highest power.
So we got B.
Absolutely not.
I'll tell you why. I thought the same thing. So here's a question. Does the carbonyl get higher priority or do we choose to go from the right side because you would get a lower numbering for the phenyl as well as the ketone? So the answer is fine. The answer is B. The answer is B.
Does everyone agree? The answer is B?
The answer is B.
Okay.
Okay, now reasoning wise, are we giving the carbonyl the priority? Is that why we're counting from the right, or is it because we're getting a lower numbering for the two substituents on the right?
Yeah.
The second,
You're getting the lower.
we want to give the carbonyl the
Yes. Okay, so in this carbon chain, we have a few substituents, right?
three.
Here's one alcohol group, second carbonyl. And then we have a phenyl group. What has the highest priority?
Carbonyl.
Carbonyl, so that means that you want the lowest looking possible for that one. Meaning that you have to start from right to left. That's it. Questions on that one?
I saw C2 phenyl, okay.
Start left to right, that means that the carbonyl would be carbon 4, which is higher than 3, so. That's why we start right to left.
What flying noodle?
Yo, we're split.
Yeah.
Go 329.
Something that takes precedence over.
329.
Yes. Perfect acids, I think esters maybe.
So I know imines can form stereoisomers because we have the double bond, right? So E can definitely form stereoisomers. Like with acids now. Formed from.
29.
We should
There's a
like,
conceptual question.
okay, so conceptually, E formed, I feel like it's E.
The imine of cyclohexanol.
No,
Cycle, because it's things like you're not gonna get you're gonna get like bacteria. Cause you can't have.
It's stereoisomer, yeah, but stereoisomers are still E and C.
There's really no E and T in the cyclo.
We don't know.
This is one of those where you, oh,
We don't know either. What about in the back?
On the helm bearing.
phenyl hydrazone.
Emily,
What?
Gonna be,
what do you think the answer is?
It's definitely not C. It's not C, because hydrazone is NH2.
Let's guess.
There's two.
I got two.
There's two NH2.
This is your option E.
I'm gonna go with E.
E,
Is it
Going E.
by any chance?
B. Anyone else?
A, B, C.
Okay, we're just thinking the alphabet at this point.
E is one of them.
It's actually A.
Now, can we draw that? Like all of that?
Yes. So first of all, they're asking you for the stereoisomer. So what am I looking for?
Double bonds,
The old one specifically I want to form
E and C isomers.
CNC.
The double bond on the nitrogen, hydrogen?
Yes, okay.
We should like draw all of them.
Yeah, for real.
Yeah. 4:30. Halfway there, we halfway.
However, I always thought.
No, we're almost with the sheet though.
Right, chop
We're
the
more than
head.
halfway done with the sheet.
That means me, maybe she's today.
If you want, just go back on her YouTube channel and just go through the SI videos. Yeah. Okay, I just.
First one, do we see how that molecule can create both the ENC?
Yes.
Yes.
That one that I just drew, what is it?
It's hydrazine.
Hydrostone, and what form is it, E or C?
E.
It's E right now.
No, it's Z, it's Z, it's Z.
E right
Oh,
now.
no, E, that's right.
E is
Trans,
anti.
E,
This one is gonna be.
That's
the
E.
form.
If it's on this.
Okay, acetone, how does acetone look like?
oh, it is.
Specifically?
Yeah, okay.
The ketone, we can see that it's equal on both sides, so you're not gonna be able to get E or C.
So where's the oxide part coming
You
in?
got one.
From hydroxylate. This guy? We do the reaction, we get OH. So these two carbons are equally substituted, so they're not gonna give you E or C, you're gonna get the same exact product either way. And then we have cyclohexanone. It's that guy, again, we have symmetry in the ketone, so we're not gonna be able to form E or C.
Right.
Everyone option D.
What is the phenyl hydrogen? Oh, it's
It's
just
the
the,
same thing, but what
you
it
just
doesn't
add
have
the
the
NH2 on the ring, okay.
Yeah.
The cyclic acetal formed from propanol and ethane 1,2-diol.
Okay, so we have propanol. And then we have. OH. Again, remember, what was the rule? Whenever you have a molecule that has two alcohol groups at the same time, what do you always form?
Cyclic ether. Maybe
It is a cyclic molecule.
oxide.
It's cyclic, that's it.
Huh?
It's cyclic, the molecule, it's gonna be cyclic.
Okay.
So with a molecule that has two alcohol groups, again, you end up with something that's cyclic.
Never understood that.
Because one of the alcohols protonates the other alcohols, and then that just makes it another leaving group.
Can we go through the reaction for that? Because that was a question on the practice exam. I didn't really understand.
There we go.
So is it the H, the O here on the acetal gets protonated by the alcohol group, right? And then I don't know where to go from there. Like, how does it actually make the ring?
Okay, so we were doing a bunch of these problems in exercise.
And the mechanism is the same for acetals and ketones, correct?
Yeah, okay,
Okay.
for example, something like this,
Okay, so you have,
very similar reaction. We start with an aldehyde and then with a diol as well. So if we're doing the nucleophilic attack, that's how we start connecting that alcohol chain. After that, you're gonna be deprotonating that the oxygen that was first connected. Or you can also transfer that hydrogen over to the OH group that you have, because at the end, that OH group needs to be the leaving group. So after that, once you have water as a leaving group, now the other oxygen on the other end is gonna do the nucleophilic attack again. It gets connected in there, that's why we have a cyclic structure. And then we kick out water, so we don't break the bond. Questions?
oh, the hydrogen gets kicked out of the protonated, okay.
Emily?
So this one's in the specific case where they're gonna form their isomer together.
For cyclic structures, no.
In general for the.
It's like a form, from what we saw in the hydrazine. Let's go back.
I need to understand.
And the amine of the cyclopentone,
This is just one of those ones you have to remember though.
Very similar.
Oh, to an R group, an amine is an R group, okay.
Again, we have symmetry in our.
amine is an R group.
Yeah, so you see how she hit the methylamine?
Hold on.
What's the region for an imine formation?
Reagent. Was it
Yes, what's the region?
RNH2?
Exactly, so that means that you have the primary amine. Okay, that's always your region. The secondary one gives you the enemy. What about question 30?
So that last part is the amine.
Yeah,
That double bonded
Is
thing.
that A? You're absolutely correct. Acetone, they're gonna be always unstable in any acids. Okay.
oh, diamond, I forgot about this.
31, diol. We briefly talked about it in SI.
It reduces everything, right? Is this one of those? Okay, I feel like the first step is just protonating that carbonyl. That, oh,
Yeah, so you would get an OH, right? On that, so to turn to make the carboxylic acid out of the ring. Cause it protonates the O. No,
Is there a split there?
so never mind. I think, yeah, no, I think there is a ring opening for the ester.
Okay, whenever we use diol, what are we trying to form?
Diacetyl aluminum hydride,
diisobutyl.
Just give me the name of the phosphate.
ester,
I don't know.
hydrogen.
Whenever you say diol, you're always trying to form an aldehyde. That was the whole gist with diol. If you start with an ester, you're gonna end up with an aldehyde.
So,
And that's out of esters and ketones or just esters?
That's with esters.
oh no, so you split it right between that single bonded O and that carbonyl. So you split it there. It comes in, okay, so that's what diol does, it turns an ester to an aldehyde and then carbonyl.
It was a very region of Canada. Literally, you only have to remember one transformation, because you are taking from west.
Just esters and aldehydes.
Ester into aldehyde?
He's not gonna test us on ketones or carboxylic acids.
No. Okay, question, again?
Ester is okay.
Yeah. As soon as you memorize the transformation, you should be
Oh,
good.
in cold weather, in cold temperature.
There has to be cold temperatures, but I don't think it's gonna be asking specifically the degree.
You're gonna add a trick question like delta, no reaction.
Yeah, I hope this one is very easy. We're
Wait,
talking about-
Oh, I'm sorry, can you go back?
C is 3. No, it's the.
For 31 was C.
Oh, that's, oh,
The one that we just did, it was C.
turn it into an H, right?
You're cutting this and then you're putting it.
Give me the number of the question and I'll tell you what the.
Don't take the last.
What is
So we know that we have to make that carbonyl into an aldehyde. So we're breaking open the chain, therefore you still have that oxygen.
It's like this.
So you're cleaving here. That's where you're cleaving. And then that O unravels.
Oh, yeah, just about the. Okay, yeah.
Yeah.
Isn't that like really?
This makes sense.
Okay, 32, what's the answer?
it's like decreasing something like.
What is the order of reactivity for carbonyl compounds towards the neophilic?
Yeah, remember these are the electric, carbonyls are electric. you know, the aldehyde's gonna be first, steric hindrance
Okay.
and electronics.
It is gonna be.
Aries, electronics.
Remember, whenever he's asking about the reactivity of carbonyls, specifically ketones and aldehydes, you're looking for the less sterically hindered one. If you're less sterically hindered, there's more space to do an attack. So that's why that one is gonna be more reactive.
We saw the less they're hindered or reactive it is. Yeah, okay.
Yes.
Quick question.
48.
It's not simple. You just want to tell me which one is an acetal.
I'm in charge.
Beautiful. 3.
Yeah.
Simple as that.
Two OR groups and an H.
Remember, it's a carbon that has 2 OR groups, which are those ones. And then if it's acetal, you need a hydrogen there. But if it was a keto, then we need another carbon chain in there.
So because it's, so. It's
We need 2 OR groups and then an R group and an H.
No. Two are, yeah, go
This one is your acetal, then your keto. Process.
So right,
On the left, now we just have your carbons. And what's the main difference? Right.
How is that an H?
there's an H there, my guy.
Remember, hydrogens are implicit. You're supposed to know when hydrogens are there. You don't see any charges on a carbon, you're gonna fill it up with hydrogens.
So for number 3, isn't it also connected to an R?
Yeah, right here.
Again, same process. We're looking for a carbon
This is a
that has
carbon.
more
This
connections.
right here is a carbon.
There you go.
R and then an H, right?
Less.
Okay,
Oh, he drew right there from.
okay, yeah, the H right there, I wasn't seeing that.
She said, where's the H that way?
I was like, where's the H? Right, like, what are you talking
It's in the
about?
five.
Okay, questions on that one? Pretty simple. Again, it's just identifying.
Imagine if H or Imagine if H.
Question 34, yeah.
Have freaking H's everywhere.
Only two, I Googled it.
Okay, we're all good?
Oh, can you go up to the one where you drew out the like the acetal and the, keep going, that one right there, the hydrazone, all that stuff,
Okay, the D.
thingy.
That was like a bullet dump, like, yeah.
Alright, we're good. 34.
Just gotta wait, yeah.
34, should it be simple again? 3. Thank
Hold up. Wait, so the following is called a tree. Cyclopentone. Cyclopentone.
One more person, what are we doing?
Hydroxylamine, yeah, 3.
Three as well.
Ah.
I was taking time.
Okay, first of all, hydroxylamine, how does that one look like?
It's just NH2 and an OH.
You know,
What I know.
hydroxylamine is my reagent, what's the name of the product? Oxime, beautiful.
That's an oxide?
That's the only oxime, so as long as you know how the product is supposed to look like, you're good.
What's the general formula for an oxide? Like the general look of an oxide?
Oh.
Lovely.
That's it.
Thank you.
Yes.
I said,
What about molecule 1? What's the name of that one?
So I just need to speak and each two.
It's a final hydrogen.
what are we asking? Question
What's the name of molecule 1?
number 1,
It's either the final.
The common name.
phenylamine.
It's metal, well, I think.
Hydrazone.
Wouldn't it be 2?
Final hydrazone, what do you mean?
No, what about molecule 2? What's that?
Hydrazine.
Hydrazine.
Hydrazone.
Hydrazone, thank you.
Wait, but what is the final?
Hydrazine to form hydrazone.
So hydrazine is just that 2 NH2s by itself.
Exactly, that's hydrazine, just NH2.
Hydrazine, so that's H two.
Question,
H two, right?
wouldn't it be
Yeah.
phenyl
This one is hydrazone.
Remember, you can't take responses.
This one is just hydrazone. Then I'm not gonna bother with 4 and 5.
Wait, you said that number 2 was hydrazine?
Hydrazone.
Oh, sorry.
Oh, chill, bro. Come on.
Oh, but I'm pushing my reality.
No,
Right
real.
now.
Okay,
Man, she needs a break too.
Hydrazine is the bleach.
she's been at this for like 4 hours.
You know, she's making her check though. I know this Friday's check.
Remember, do any figures.
Hydrazine to any sugars.
That's it, simple as that. Questions so far, we're good? We're good. 35.
Me, that was fast. Vehicle?
He got tired, because he pulled up to see himself.
Yeah, it is gonna be B.
That's your hydro. Sorry, your hydrosol. What's the name of molecule 1?
That's
Reacts with hydrazine.
and is there like iron?
Phenohydrosol.
Why is it 2 if you just wrote hydrazone?
Okay, so the
Hydrazine is the.
There's a difference.
hydrazine is the key thing in this
Phenohydrosol
entire
or
question.
hydrosol.
The rest are hydrazine. You got
You
one.
see a benzene, it's a phenohydrosol.
Like Roxy, the
You got a hydroxamine, this is a.
Yeah.
And then this is the, what's number 4 technically?
No, we don't really go over that.
We didn't go over that? So that's just a cluster book, you don't even know this.
Exactly.
Right,
Same thing.
and then
Oh, no.
number 5 is like nitrophenol.
No, this right here is all,
You have nitrogen. Yeah.
that's an imine, I think. Imine.
That's not an imine. Number 5 is the imine.
Those 2 ends.
It's not an imine.
No.
An imine is what?
Okay, what's the basic structure of an imine?
Imine,
Imine is.
Oh, it's supposed to be larger, not 2 ends. Okay, that makes sense.
Or NH2 for imine.
Or any.
Or like your carbonyl group with your NH2, and then imine is like NH, and then the 2 carbonyl groups attached to it, since it's secondary.
imine,
NH.
enemy. Alright.
The main difference was where the double bond was placed, where the E is directly to the nitrogen, sorry.
The enemy is one away from the nitrogen.
But it's not like an end binds to another end.
No, yeah, no.
Would that be a hybrid? Wait, so scroll back up then? So then, oh, but it's an end that's attached to an end that's attached to an R. Yeah, hydrazone, right?
One's next to each other, that's a.
So number 5 is a hydrazone.
It's some sort of hydrosol, specifically that name, I'm not sure.
Doesn't apply, okay,
Yeah.
but it is a
But
hydrazone.
technically, yes, they fall under the hydrosol form.
So all of them are technically hydrosomes.
Molecule 3 is not hydrogen, it's an oxide.
Yeah, besides 2 and 3, besides 2 and 3.
Yes.
Okay.
Okay, so let's talk about Wittig.
Wait, 2 is a hydrosome? 2 is a hydrosome?
Two is a hydrazone, yeah.
Okay.
You used a hydrazine.
And then it became a hydrosome when it lost any
Do you mind
H2.
like explaining the mitigation again, please?
Freaking hate
Oh,
mitigation.
yeah, this is, bro, I just.
Guys, how many of you remember the Wittig reaction?
All I remember is that the P
I see 2 hands, 3 hands.
They've been studying this.
It's the only one with the phosphorus group.
You probably felt that.
That one
Was a retrosynthesis.
synthesize.
I mean, let's go back to the handout, chapter 16.
It's B, I'll tell you why. Just look at where the double bonds placed. That's all you gotta know.
I was gonna say 2 or B, but I don't know why.
Oh, sorry.
Trust me, go, bye-bye. I got them sticking with this.
Oh, you made it so easy, the professor, I don't know what the professor did.
The Wittig, thank you.
Yeah, but.
Yeah, the professor, it's like, so the question was,
Chapter 17. is
which
chapter 17.
elite makes this product?
That was basically the question that I just gave you.
Scroll back up?
It's not in here.
Or wherever it was.
Not in here. Okay, so really quickly, before we go through the question, let's review Wittig. So remember, for Wittig, what are the 2 main reagents that you need?
Phosphorus.
How's the name of the reagent? What's the name?
Elite.
Illid.
In Illid.
Illid, exactly. How do you make the illid?
Three phenols and a phosphorus.
That's one of the reagents.
So
Then-
oxygen double bonded to the.
No, how do you make the illite? One of the reagents is a phosphorus group with 3 phenyl. Or we're here, guys, making the illite. Phosphorus with 3 phenyl groups,
You use a Lewis acid,
alkyl halide.
alkyl halide.
Alkyl halide, yes. So whenever you see those two combined, you're making the illite. After you make the illite, now you can proceed with your Wittig reaction. So we need the illite, and then we need some sort of ketone or aldehyde. Okay, again, very simple. You just chopped off the heads, and then you just connected the legs. So pretty much your heads, those guys are your byproducts. We don't really care about it. And I want you to notice where those R groups are going. Okay, so again, in your product, you end up with an alkene, just a double one, that has pure R groups. Those R groups, they're coming from your ketone or aldehyde and the illite. So let's go back to the question. Do you need me to go back?
No, you're good, you're
Okay, we're good.
Chapter 16.
Let's see. Okay, so in this case, we're given that product. They're asking for the reagents, so it's retrosynthesis. Again, remember, the legs, they're coming from the reagents. So think about it, there can be a few options.
You said E?
What are they?
Either one or two could be
Oh, wait a
used.
minute. Yeah, no, it's E.
Wait.
There's one-
Oh, one or two are used together because by using these two is what you get the methyl. And I mean, depending on what reagent you use to complement one or two is what you use. So yeah.
So final answer, what do we think?
E. You mind going back to that illite formation? That was.
There you go.
Yeah.
Gracias.
Yes. To find this.
Okay, we're good?
Maybe just have.
Okay, guys, again, it's been an hour, so you guys get your little break.
God bless.
Get your little break.
I have a great idea. Great.
Yeah.
So
Get rid of all this.
Yeah.
These are both gone.
Oh. You made it like.
Oh, yes, yes. Oh.
Yeah, I don't know what he did on the board, but it didn't
You
make
showed
sense.
probably the full mechanism, which is confusing. It looks like a square.
Like here it's just,
Just split
you
it,
know,
just split it and look at the connections.
So you said, there might be like one
yo,
Wittig
that's
reaction
dumb
question.
easy.
There might be like one Wittig reaction question. Cause I remember like in SI you said not to focus on it too much. We didn't see that. You said like, you might not really. I just focus on it.
Yeah, usually there are not that many Wittig problems,
Yeah.
but based on what I saw in the projects exam, there were a couple, so you might get 2 questions. Because at the end, remember, it's still gonna be 50% 15, 50% 16. You have like 35 questions or so think about that one too.
Yeah.
So this pretty much might as well be the test.
There was not a single Wittig reaction on all 5 of the attempts I took on that practice exam. I'm positive I took them over.
Let me check. I actually got the,
I have pictures of all the different questions I had too.
Yeah, I took a video of that.
Yeah, no, you do it now because you don't know when you're gonna get it. or not.
Exactly.
It's half of these questions. are big, or- No, you know, it's just you do it all the time. Whatever, it doesn't matter.
So I was gonna go through. And then read.
Yeah, you know, like, okay.
you know, Mira, carnal, hay one that I will say. Just. We call, we get cold, we bleed red. You bleed red, I bleed red. We all the same. It's, what do you mean? No kid.
Then sit down, take it without doing
Yeah.
I don't have big.
Huh?
You must just have.
Yeah. Nah.
Oh, that's not like ATM, but James.
Oh, you sure said I'm
Wait, like you move your mouth, but
What if people keep, yeah, we move. No, but honestly, I think we move ourselves more than we.
Huh?
Wait,
I mean, the you is subjective, who's talking to you? That's
who is we?
It's just it's not, yeah. We're used to
See, I got this one wrong, but because I picked five beginning on this. Just remember the question. Oh, the question is.
What is the
No, we just did it, we just did, I don't know,
Okay.
it's just the, you know, CL is substitution, right? But I got this one wrong because I thought. You know what I'm saying?
Damn, that's first.
It's like, oh. But it's like a.
Last hour.
So it's like you.
Yeah, I'm gonna get into the give me time.
Yeah.
How many times have you done
I got 33 on both.
It's not that.
Actually, got 30 pretty good though.
30 is probably the-
No, 33 votes.
No, we're out here.
Right, so it's 33 out of 30. That's why was
Again, it's at a completion, all right? Don't forget you get credit.
Yeah.
Alright.
Unless we go. But he's not.
Don't tell, don't tell.
Wow, yeah.
There's so many benefits.
You got hype in the two that are. Right, like, oh my god. Oh, wait, who never sees that yard? Those are like, those are like, that's great.
What am I gonna do? I haven't heard this song in years.
Oh, you doing chemistry over there?
Oh, you still?
No, it's because I have chemistry, but I used to keep this.
I just use it like. I back.
Yep.
It's back to, hold your reagent down. I think I'm gonna buy,
And then I'm looking what's
It's Erlenmeyer class.
Probably better than
Gotta keep checking.
Yeah.
That's one way to do it.
Okay, I might just wait for all.
Alright, 37.
You know, ruination, like, you know, I get the.
The quicker we finish, the quicker we can leave.
Yeah, honestly. The people.
Oh, nobody can eat little baby. I just, I'm watching Digit every night.
Yeah, this thing playing Pokemon Go. What?
No.
Yeah. My kid. This man just called me off.
Question, I know I have like a C in my class right now.
It's working.
Yeah, I mean, I know that's not, that's nowhere near competitive for.
I think we're all back now.
Honestly, man, the way.
We're good, right?
it's like, it's that, helps a lot.
So we can keep going.
And I'm down for it, you know what I mean?
Keep it clean.
Whatever.
We continue.
Should I give it one of?
No, that's-
Another Wittig reaction.
Another way.
So we know.
Okay.
What is the
Chop,
reactant
chop the head.
in? What the hell is a W there for?
Reactive W.
Oh, the reactant W.
I thought that was tungsten for a second, like we're doing inorganic?
I thought she meant like within the synthesis below, like she's ready to written.
Oh, wait, no.
One for C,
I mean, W.
No, I'm sorry.
It's okay.
one for A.
No, as far as setting my.
Yo, relax, relax,
Well, I vote A.
relax.
How about A?
This, which goes to.
Cause it's like little pins, you know, you gotta carve.
Yeah, it's a. That was the easiest problem we got all day, okay?
Yeah, you was before, he explained how easy it was. Like, I don't know what.
It's not a. Put that on you.
Careful.
Oh, it's D.
Bromocycle penton.
Why the D?
Wait, pentane, oh, because you need a halogen to swap out for the, oh.
That's what it was. Okay, you need a
You
halogen.
need the alkyl halide, exactly.
Your hairline.
So in this case, this
So
portion
you need one
is
ketone,
making the illid.
so you need one carbonyl for the illid, and then the other has to be a halide?
So to make the illid, remember, you need a phosphorus group with the 3 phenyl groups, and then you need some sort of alkyl halide. Those are the main reagents that you need to make the illid. And then once you have your illid, the Wittig reagent, which is the illid, can react with any ketones or aldehydes.
Don't tell.
There we go. It's not that one.
No, what is the? Right.
Or Wittig.
So you're forming a Wittig with a methyl and a,
It's gonna be, what is that, a double bond to the methyl.
is that like a toluene?
To an ether.
You're forming a, it's a methyl and a benzene ring.
Which area are you looking at?
I'm looking at the very initial step of CH3I reacting with the C6H5.
Sorry, that's a phosphorus
Yeah.
connected to 3 phenyl groups.
Okay, so that just has nothing to do with that, but the C6H5Li is,
Oh, yeah, that's a benzene.
so again, you're gonna end up with a toluene. No? No,
Could it be a?
so, do you have anything to add?
Wait, can you scroll back up just a little bit while keeping that question in, just to kind of refer to, yeah,
Okay, alright, I can buy with that.
because you're saying you need that with an alpha halide, which is what we have.
So we have that with the. What is the final product? So you're chopping that off and you're just putting on the methyl.
You're making it
So it's
either,
A, it's A,
you're adding a methyl to.
it's A.
They're in agreement?
Wait, I lied, give me a sec.
So for the previous reactor, we didn't use an either, but in this one we did, so is the either gonna be in the substituent?
Oh, that's a good point, the ether and the substrate, under the C6H5Li.
Just your inner solvent.
Okay, so
It's a
okay.
non-reactive liquid.
Okay.
Um,
Wait, C6H5, and then you got the carbonyl and then you got the methyl.
oh, okay, I got it, so then it's gonna be the ketone, but instead of the O, it's gonna be a methyl.
Literally, that's all it is, I'm
Yeah.
trying to look through the. I have to change my face.
It's A, it's A.
We think it's A.
I think so.
Wait,
What about in the back? That's okay.
yeah, we go with A,
Yeah, you see that, right?
yeah.
Either like that. Now, Chris,
So you guys have an actual reasoning why it was A?
Yes.
can you explain, please?
Now you look like you gotta cry.
I need it.
Yes, I can explain.
Okay, man, get back in my copy pieces and actually.
That's okay, we can ask for help, that's completely okay.
That's why we're here.
Okay, either way. So in this case, you're presented with multi-step sentences, but everything is related with wedding. So first of all, we have alkyl halide plus the phosphorus reagent. Let's look back at the previous one. We had an alkyl halide and the phosphorus reagent. That's the one that makes Wittig. The Wittig reagent. Which we know is just gonna be the illite. How is that illite gonna look like?
Just a mental.
That's all it is.
This is your illite. Double bonded to a phosphorus that has 3 phenyl groups.
The illid is all.
So, oops, sorry. Okay. So you're forming the whoops. You're forming the illite after you have the base. Usually it's just gonna be a benzene with a lithium. So after you see that, the lithium, that's how you form the illite. So now you have, let's use another code. This guy plus your ketone. What was the shortcut for
Chop off the head, wedge in the.
chop off the head, that oxygen and that phosphorus, connect the legs?
So question, why do you have a double bonded CH there, like a carbon there?
Because if I don't show the double bonded portion, the shortcut is gonna be, it's not gonna look quite the same. Because remember, the active illite, what we actually need for the reaction has charge separation.
Mhm.
That should be correct, as far as the mechanism goes. But for simplicity of the shortcut, I just like to keep it in the inactive form, the double one. So it's more clear to see what's gonna be the head, what's gonna be the legs.
Used. So illids are always double bonded, or just in this case because because of the reaction?
I think they're always.
Illates are always gonna have some sort of double bond. But again, we have the active and the inactive illite. Okay, let's go back to this one. So it may be-
Wait, you just added extra carbon?
Hold on. We're going back,
Yeah, I'm looking at it.
Okay, so now, we have the inactive illite and we also have the active illite. They look the same, but the only difference is that one of them has double bond, the other one has charge separation. The charge separation, that's the one that we're actually gonna be using for the reaction. It's gonna be the one that's reactive.
So again, an illid always has a pi bond? For the sake of this example? Okay, love it.
And then let's just color match this portion.
Sometimes a little bit of trouble to figure out how you made that, the illid, where it's just one carbon. I'm saying C6.
Oh, my friend, you're all getting married.
Bro, I
Like, what
moved.
the fuck?
Everybody needs you, baby.
I'm always getting engaged, oh, they have getting married, and we're still. Like, I'm still an undergrad.
You got it, okay.
That's good.
And I'm worrying about winning.
I think just think, oh. Well, no,
It's your-
we'll make
Oh, I can't wait for lab. Actually, I'm losing. We say this now, so we have to write down lab reference. Huh? No, it's just the writing room.
Like, yeah, but like, I'm talking like the link is
Yeah.
over, I think,
Really?
screenshots. Yeah, you got writing for sure, explaining the finding, but like.
You're basically connecting the carbon chain to the outside. to put the remaining with the.
No.
Okay.
But there's remaining,
This your
I
reagent with phosphorus, and then you have your alkyl halide.
just want you to eat a top.
Phosphorus attacks the carbon with the leaving group, and we kick it out. So now we form this guy. This one is still not the alkyl. Why? Because we have to keep protonate this. So, or base, the one with lithium, takes away the hydrogen, so we can finally get a negative charge.
The active.
Remember, in chapter 16, your reagents, the ones that are presented in the arrow, those are your nucleophiles. So it makes sense that we need a negative charge in here.
So the phospho group is always going to be the positive end,
Yeah,
so that means the carbonyl is the positive end. Because the carbon is, it's detaching from the phosphorus and like attaching to the carbonyl.
Question,
this carbon has a negative charge at the end.
Never mind,
question, what if the,
conceptually I understand.
what if the alkyl halide had, 3 substituents? Like I'm saying, like R1, R2, and R3 instead of H, would it react? Right, cause, yeah.
Yeah, we need to get rid of some sort of hydrogen.
Oh, because you have to get the negative charge on the carbon, and there's 3 substituents and the phosphorus, talking to the negative charge on the carbon.
No, you won't be able
Say
to.
that one more time.
Or like, you know,
Yeah.
As far as the mechanism goes, the active elite is the correct one to use. But for the exam, you can just use the inactive one. So the shortcut is easier to see. Okay, yeah,
So he's only gonna put like maybe 1 or 2 on the exam, right? You think?
I think so, yeah. Max, I think you might see just 4. Max.
So.
Max, I think you might just 4.
Okay.
Because again,
I
remember,
can see why
the
you.
exam is gonna be 50% 15, 50% 16. So, yeah. He can ask you the same questions over and over again.
He has done that too.
He has done that in the past, yes.
It's bullshit.
Okay, this one is 17.
I don't understand conceptually.
In this regard,
Wait.
No, 17.
That's 17?
Yeah, chapter 17.
yes. Yeah, we don't focus on 39, 40, 41. Those are chapter 17.
Don't worry about it.
And now we're back to chapter 15. We're not done yet.
Which reagent would you use to carry out the following transformation?
This one?
Benzene.
Okay, I think that's.
Alright.
Okay, are we good?
With the sulfonic acid, it's gonna be SO.
Or 42.
Okay.
Benzene,
Yeah.
sulfonic acid, so para is SO. 3H.
Yeah.
That's a.
That's what's weird, and then,
Oh,
wait.
ortho.
So, yeah.
That's what 3H.
What's the answer? They're asking for the reagent.
B. No, but it says.
D.
Oh. Absolutely correct, it is.
Yeah.
Stop playing with them. Stop.
With benzene, you're gonna end up with benzene sulfonic acid, but sulfur, we're doing a sulfonation. So as long as you remember how the reagent looks like, you're good. Yes, of you was just there to confuse you. Yeah,
Alright,
it was just there to confuse you.
how would you make this compound?
Frederick synthesis.
You start with the carbonyl, you start with the carbonyl.
No, you start with your benzene.
Those are the 2 main reactions that you're doing. What's the order of them?
Oh, it goes halogenation first.
Yeah, it's orthopara.
No, but halogenation adds an orthopara, so here's the thing, you can't form that compound.
Oh, relax.
No, you can't, because that's a strong deactivator.
It's an acyl halide, so I know first.
Okay, so in this one.
So can you hypothetically not form that compound because an a halogen can be added in the presence of a strong deactivator, which the carbonyl is a strong deactivator.
No, it's. No, no,
It's going too far.
this is an acyl, this is an acyl
Okay.
condition.
Okay.
Go ahead, go ahead.
It's telling you the molecule's already formed, so how are you gonna say that? It's just asking you which one goes first.
Alright, so you don't
Yes.
watch.
They're just asking for the order of the reaction.
Is it halogenation first and then acylation?
So, to add the bromine, we know that we're doing a halogenation.
And it's yeah, you're not.
Yes, there, that goes to which position? Order here. Beautiful. What about the
One
ethyl
You're
group?
going through it.
That's
That's a strong deactivator and it adds in metal.
No.
What kind of reaction is gonna add that acyl group?
Acylation.
Okay. What's the relationship between those two groups? Are they ortho to each other?
Meta to each other.
They're meta to each other, which is the only one that's gonna add meta.
Acylation. So
Acylation.
you do acylation first. But my question is, can halogenation work in the presence of a strong deactivator?
Yes.
Work?
Halogenation.
You're definitely saying acylation there, right? You keep saying that, but you gotta go out now.
Okay, so this reaction, we're doing an acylation of bromine. Bromine is the weak deactivator. So the reaction is still gonna proceed. Remember, Friedel-Crafts reactions, they don't happen with amines or strong deactivators. Bromine is a weak deactivator, so it can still proceed.
Shoot.
She said.
Do we have bromine here? That's it.
This would be the fourth, this would be the.
Then who is that?
Número diez.
Any questions so far?
43.
43, yeah.
43. Stop playing mumble.
Okay, we're good? Abigail. What? For this one? Yes. Okay, so again, first thing that you're gonna do is identify the reactions that you have to do to add them.
That was it?
So-
Alright, boys.
We know that we have to add bromine and an acyl group. So we have two reactions, halogenation and acylation. Next thing that you have to notice is, yeah.
You're posting this?
Yeah.
And
Next thing that you have to notice is what kind of directors they are. So halogen, that's a deactivator, but it goes ortho and para. The other one, the acyl group, that's the strong deactivator that goes meta. After you know those facts, you have to look at the relationship of those two guys. Since they are meta to each other, I can only do my acylation first. Because if I were to do my halogenation first, then my the relationship is gonna be either ortho to each other or pair to each other.
Okay, yeah, that's a really nice.
Okay, so before you guys start just packing your stuff and going away, any last minute questions on chapter 15, 16?
No.
We're good. Do we wanna do more practice? Bro?
No, let me get the hell out of here.
We're good, okay. Thank you.
Yeah, you can go stay an extra hour here, right?
I'm not gonna say, so if you have any questions, just feel free to come up here. Yeah, if not, you can be free.
Good luck studying, boys. Good luck, good luck. Come on.
Yeah, boys.
Just wait 5 minutes.
I have a question too. Take a break right now. No, we're done. We're done.
We're gonna do practice problem. You wanna say?
I can say, right? Okay, so this is kind of like, this one.
Yeah.
So
So
that's.
remember, like, those are your options.
But it seems like ethers, experience, and heat, so they're all active. Those also have. So since this is like directly. So that oxygen. Twice.
When we have the carbon was listed on our next priority. Two carbons inside of another. If the carbons, we have the carbons on our side, we have them all the time.
No problem.
If you guys wanna come closer, you guys can come closer. It's okay. Yeah, it's gonna move. We just wanna stay in the back, that's fine.
Okay. So first of all, I have a request to go over Whittick again. Any other requests? Okay, we all wanna go over Whittick again. So do you guys want me to start with a practice run? So go back. Explain the basics. Back to the basics, back to the basics. Okay. Let's go back over here. This one is the chapter 16. No. Okay, so for your Whittick reaction, you have two main reactions. You have something called a inlet plus either a ketone or an aldehyde. Those are the main components that you need. Now, the basic structure of your inlet, how does it look like? Do I remember?
Express with 3 funnels.
Phosphorus with 3 phenols, that's the main portion. It's a phosphorus that have those guys. And then on the other end of the phosphorus, you need some sort of R group chains. Which is called R1 and R2. That's just the basic skeleton of your inlet. Okay. Now your ketone and aldehyde, those ones pretty simple, just a carbonyl with 2 R groups on both sides, so either be 3 or 4, or an aldehyde, or 3 and hydrogen. Okay, now, as far as the ergot goes, remember, your head for your ketone and aldehyde is always the oxygen, so get rid of that guy. Then, for the inlet, your phosphorus, now gonna be the head, and again, we get rid of them. At the end, the heads are gonna get together, and that's gonna be your byproduct, but we don't really care about it. The main portion is the Whittick thing. Now, after we know that we're crossing out the heads, you're just gonna keep the legs together. So I know that I have double bonds that are connected to the R group, so I'm just gonna start by drawing my double bond. Okay. We starting to remember? That's good. Okay, so we are gonna be adding the legs of the inlet, for example, R1 and R2. And then whatever legs you had on your ketone and aldehyde, like R3 and R4. That's it. Question so far? Do you remember this from aside?
Yes.
That's good. Now, that's the main portion. Now, for the inlet. Sometimes you're gonna get multi-step synthesis reaction for Whittick, but the only thing that you have to worry about is making the inlet and then doing your Whittick reaction. So let's talk about making your inlet. What are the main reagents that you need to make an inlet? You need the phosphorus. The 3 phenol groups. I think, yeah, that was it. And then you needed some sort of alkyl halide. So basic structures are phosphorus plus R group with some sort of halogen. Let's say that we have that alkyl halide. Now, we know that halogens, they're always gonna be your leading groups. So this one is gonna be very similar to the shortcut that we just did. We chop off the head, in this case specifically, it's the halogen that you have. And then let's go back to the original reaction that we did in here. Basic structure of an ellipse, it's a double bonded phosphorus to a carbon. We have R groups and phenol groups, that's it. So I see my phosphorus right here. Okay, perfect, I'm just gonna start drawing this guy out. Phosphorus, I know it has to be double bonded, let's just start simple as that. And that phosphorus is connected to the phenol groups. So let's just attach them over here. And then we are just missing the legs, the little R groups at the bottom, that's it. So I start drawing 2 connections in there, and in this case, I just had CH3 groups in there. I'm just gonna draw them. That's it, simple as that. As far as the reagent goes, you're gonna see some sort of base as well in here. Usually, it's gonna be benzene with lithium. That's gonna be the most common base that you're gonna see. So again, you're doing your ellipse after you're presented with the base, after you're presented with lithium. After that, chop off the heads, join the legs, that's it. Simple as that. Questions on what it is? We're good?
What's that right there, you drew the R3 and the aldehyde? What is that right there?
This one?
Yeah.
That's just supposed to represent any halide, sorry, any aldehyde.
So you can make the way with that, like,
With 2 R groups, yeah.
if there's no R group, you can do it with the hydrogen on the end?
Yeah.
Okay.
Because remember, all the chapter 16 reactions can work with any ketones and any aldehydes. Any other questions on winner? We're good? Okay, what else are we gonna work on? Abigail. Yeah. You don't have to worry about the mechanism, it's a little complex. Okay, what else do we want to cover? We have 30 minutes.
You go with this, and how would you send the exam?
Okay, now that we know the concepts, we can actually go back to the review and see those ones again. Okay, they're right here. Okay. Let's start with that one, that was simple. So one of the questions that he can give you is retrosynthesis, okay? Now retrosynthesis, we know that we're given the product, and we know that we're trying to find the reagents. Now, I know that my final product, it is a double bond with R groups connected to it. Now, the R groups that you see in those double bonds, they're coming from the ellipse and the ketone or aldehyde that you have. Okay, so we have 2 main reagents. Let's just say carbonyl plus ellipse. What's the head of the ellipse? It's the one that has phosphorus. Phosphorus with 3 phenyl groups, that's your head. What about the head of the carbonyl? What is it? The double bonded oxygen specifically. Okay, we just start with the basics. Those are the head, I'm gonna go with my byproducts. And I know that those guys are double bonded. Okay, now they're double bonded to whatever R groups I have at the end of my product. Let me redraw this guy. Okay. So if you're given retrosynthesis, you can start like this and then look back at your problem. You're gonna split it right in half. Why? Because you're seeing the connections in both ends. So, and that carbon on the top, we're connected to a carbon, and we're also connected to a hydrogen. And the carbon at the bottom, connected to a carbon and a hydrogen. So I know that in both of my carbonyl and ellen, one of my legs needs to be a hydrogen. So in this case, let's just start drawing the hydrogen and the hydrogen here. So far, do we see it? Now, the only portion that we're missing is the carbon chains themselves. Now, your carbonyl and ellen, they can have either of those carbon chains, okay? It doesn't really matter. So let's just say that the one on the left, this guy, I'm gonna make it into the carbonyl. So I'm just gonna be adding one carbon that has that cyclopentane. Then on the other side, I just need to add one methyl group. So there we go. That's it. Now you can also swap them. Those two can be your reagents, or we can also have either of those sets of reagents are gonna give you the same exact thing. These two together, they give you the product, or those two together, they also give you the product. Questions? Do we see it?
And a Wittig reagent is just another word for an illid.
Yes.
Okay.
Your Wittig reagent is your illid. Any other questions so far? We're good? Okay, what else do we want to work on? This is basically like a tutoring session right now, so it's up to you guys. No problem, take care. Do you have any other questions? Yeah, we just want to stay here until. Yeah. Either way, you have to stay here until 6. That's a little okay.
Just throw like a random question. Like a random question.
Or from any chapter? Or. Problem, make you take care. I was reading.
Thank you.
Problem, take care. First of all, what chapter is that from? 15. Okay, where are you talking about? No. What's the name of that functional group? Alkyl halide. So what reaction are you trying to do? Alkylation, beautiful. Okay, now. What's my next step?
Split the two, draw a line.
Just split them right in half. Take a look at what's directly connected to each of the benzene groups. The one on the left is connected to a carbon. Carbon chains, are they activators or inhibitors? Activators. What about on the right side? We have benzene with an oxygen. What's that? It's an activator as well. So remember, that was one of the 3 scenarios that we talked about during SI. If you have 2 activators, which one gives you the major product? The strongest one, the most reactive director. So what's stronger, carbon chain or oxygen? Oxygen. And we know since it's an activator, it goes ortho. And para, if I'm looking specifically for the major product, where am I gonna add it? Ortho or para? Para, because it's less likely hindered. Okay. Questions on that one? We're good? Do we see it? Try another one.
Get rid of one of the hydrogens on the nitrogen and then chop off, is it the hydrogen off the aldehyde? Or is it the oxygen?
Okay, so first of all, what chapter is this from? This one's tricky because it has both key portions of each chapter. We have an aldehyde, that's 16, but we have a benzene here, that's 15. Whenever you have something like that, you have to look at the reagent. This reagent, what kind of functional group is that? It's an amine. We only saw a few reactions with amines, which they were all in chapter 16. Now, we had two main reactions with amines. It depends on the degree for that one. What's the degree of the amine? Primary in this case. Primary amines. What do they form? The amine. What's the shortcut? Chop off the head. Get rid of one hydrogen. Get rid of one hydrogen.
The antidote carbon.
Remember, we keep the legs together and then whatever was left over from your reagent goes over here. That's it. Questions? Do we see it? We're good? How do you guys feel with IUPAC? Pretty good? Okay. So we're gonna skip that one. Let's see. What's the problem? What chapter is this from? 16. Sweet, beautiful. 16. What kind of reaction are you trying to do? Wetting, beautiful. We see phosphorus, automatically wetting. Which one is your L? The right one. And then on the other side, we just have an aldehyde. What was the shortcut for wetting? Chop off the head, so we chop off that oxygen. What's the head of the L? And then what are you gonna connect? You're gonna connect the legs together in that side. Simple as that. So we have the legs for my aldehyde, which are double bonded to the cyclohexane. Questions?
I guess the simple way to do it.
So the double bond always stays when you jump off the head.
Remember, for Wittig, you're always trying to form an alkene. Because pure carbons, that's it. I don't want oxygen, I don't want phosphorus, anything.
Adding a carbon in the middle of that addition. And then it's like. Makes sense.
Yeah. Sorry. There we go. You have to add one more little carbon in here.
You always have to have next one.
For the sake of the octet, yeah. Okay, what about? Let's do retrosynthesis.
You have to look at what.
You're looking at the product, you have to tell me what reactions you're doing and what's the order of them.
With the NO2.
Okay. To add the NO2, what kind of reaction is gonna add the NO2? I heard a little whisper, nitration. Bromine, what kind of reaction is gonna have just bromine?
He asked us more things like, what's the reagent, not actually like the name of the reaction. Like when he asked us like HNO3. Like
He's gonna give you the reagents themselves. Yes, he's not gonna give you alkylation, halogenation, any of those guys. What kind of reaction is gonna add a pure carbon? It's one of the Friedel-Crafts reactions, but which one specifically? Alkylation. If I were to have a carbon somewhere in there, then it would be acylation. We don't have it, so it's just alkylation. Okay, so we have the three main reactions. What's the order? What are the reagents?
is alkylation first.
Why is alkylation first?
Because it's later and.
There we go. Those are the complete opposites.
Like, if nitrogen was first, hit the other one.
Exactly. Remember, Friedel-Crafts reactions, you have to be careful with those guys. We're doing alkylation, so that means that we can add the strong deactivators first. So one of the possible answers could be alkylation first. And then what else can we do? Halogenation and then nitration. What's another order?
Halogenation, alkylation, then.
What's the last order? There's one more. What else can I make it with? We can do nitration second. We can start alkylation, then nitration, and then halogenation. Yes.
So alkylation has to go before you do the
Nitration version.
Okay, so halogenation can do whatever.
Yeah, because at the end, halogens are weak deactivators, so Friedel-Crafts can proceed.
I thought the third option would be the nitration happen like para. So then it wouldn't be like.
You're also gonna get the ortho product.
So whenever you like measures make it, the alkylation and then prepare nitrate. That's up. Since the halogen isn't there yet, then it's not certain that we take it into verify.
Not necessarily, so for retrosynthesis, we're not always focusing on making the major products. We just want one specific product, it might be the minor one, but we want that specific one. Okay, for the alkylation, what's gonna be the reagent that I'm gonna use? The main reagent and the solvent. AOCO3, okay, that's my solvent. For the alkylation. That's another one that I could also use. Something like this can also be the starting one, because remember, at the end, chlorine goes away. You're left with a primary carbon, but we can do a hydration. Making it into the tertiary one, sorry, the secondary one. Okay, what about nitration? What are the reagents that I need? HNO3 with 2SO4. Last one, for the specific addition of bromine. What's the reagent?
No, they like bromine.
This one? The BO2. Remember, if you're just adding pure halogen, your reagent needs to be pure halogen. Because this guy is gonna create an alkylation as well. In this case, oops. It's just gonna be BR2. What's the solvent? BR3. That's it. Questions? Very good, you will see it. Okay, any other last minute questions? Good, we still have 5 more minutes, so you guys are free to go, or you can stay if you have any thoughts. No problem, thank you guys. You didn't need.
I guess when they turn
You
the
just have
on.
to spin it around. It's on. It's off. No. License. Sorry. Yeah. I think we don't really. Yeah. it's very good. What's the news? Then is gonna be similar to the practice then, like it was. Really done like that. Like your questions as well. Yeah, especially the practice problems that he posted. They're not. Thank you, Jen. Thank you. No problem, guys. It should be under modules. Let me. Oh, and